Okay, so here we go with the last problem in chapter 3, page 9 of 9, all done after this one, linear programming. Let's just jump right into it. Jasmine's recipe for very berry smoothies, which sell for $3 each, uses 6 ounces of berries and 2 ounces of bananas. Her recipe for tropical smoothies, which sell for $5 each, uses 2 ounces of berries and 4 ounces of bananas. If she has 90 ounces of berries and 80 ounces of bananas available, how many of each type of smoothie should she make to maximize her revenue? What is the maximum revenue? So this tells me my variables, how many of each type. So I'm going to say that X is going to be the first one, so the number of VB smoothies, very berry smoothies. And then Y will be the number of TS, tropical smoothies. Oh, T smoothies. I don't even need a TS, I just need T smoothies. Right. Maximize revenue, so I know what my objective is. So then when I write my objective function, I know it's going to be a revenue function. Now, very berry smoothies sell for $3 each, whereas the tropical smoothies sell for $5 each. So I know it's going to be $3 times the number of very berries plus $5 times the number of tropicals will be my objective, my maximization function. So I'm going to maximize that. I also need to figure out my constraints. Now, the only constraints I read in here was the berries and the bananas that she has to use. Right? I know that a very berry smoothie is 6 ounces of bananas, so 6 ounces times the number of very berry smoothies, plus 2 ounces times the number of tropical, and I cannot exceed 90 because that's all I have on hand. Right? Using the same logic for bananas, a very berry uses 2 ounces of bananas, and a tropical uses 4 ounces of bananas, and I cannot exceed the 80 ounces that I have on hand. Again, these make sense here. And again, this one is another one where it would also make sense to say that I can't have, I have to have integer values. I can't have a half of a smoothie. All right. Boundary line for the first one is going to be 6x plus 2y equals 90, which is going to have an x-intercept of 90 divided by 6. So 90 divided by 6 is 15. A y-intercept of 45. Okay. The boundary line for the second inequality is 2x plus 4y equals 80. It's going to have an x-intercept of 40 and a y-intercept of 20. And we can go from there. All right. So I'll go ahead and make a sketch of this. I know I only need the first quadrant. My largest x-intercept is 40. My largest y-intercept is 45. So if I put 40 all the way out here at the end, that makes that 20. There's 10. There's 30. And 45. So I could put 40 about here. And that's 20. There's 10. There's 30. About there would be 45. I'll go ahead and sketch these things. I'll use pink for that first one. Goes from 15 on the x to 45 on the y. And I want less than for that one. So that means it's this piece over here. I'll use orange for the second one. The boundary line goes from 40 on the x to, was that 20, right? That was 20 on the y. And I want the less than 80. So I want below that. And so then where are they both true? Well, they're both going to be true right in here. That's going to be my feasible region. I know I'm going to have a corner here. I'll call that one A. And I know that A is 0, 20. I'm going to have a corner here that I don't know yet, but I'll call that one B. I'm going to have a corner here that I know. I'll call that one C. I know the C is, what was that? That was 15, 0, right? And technically, I do have a corner here we'll call D, and D is 0, 0. How do I find B? Well, B is the intersection of the boundary lines. So it's the solution to the system, 6x plus 2y equals 90, and 2x plus 4y equals 80. So I'm going to grab my calculator, go to my matrix menu, edit that matrix. Ooh, that's a 3. 6, 2, 90, 2, 4, 80. Second quit, second rerun that command, and I get 10 and 15. So then that corner right there is 10, 15. Now that I know my corners of my feasible region, I'll plug them all into my objective function, which was way up there, 3x plus 5y, and see what happens. At corner A, z is equal to 3 times x plus 5 times y. That's 100. And this is revenue measured in dollars, so $100. B, z is going to be equal to 3 times x plus 5 times y. 50, 75, 30, 105. C, z is going to be equal to 3 times 15 plus 5 times 0, $45. And at D, I do it because I have to. I know that it's going to be 3 times 0 plus 5 times 0, which is just a big fat 0. Which one's the biggest? So then what should Jasmine do? Is it Jasmine with an E? Jasmine with an E. Should make 10 very berry smoothies and 15 tropical smoothies for a maximum revenue of, what is our maximum revenue? Oh, $105. And that brings us to the end of chapter 3. Next week we'll do chapter 4, or the next video series will be chapter 4. And what we're going to do in chapter 4 is we're going to take this idea and do it for more than 2 variables. So notice that everything we did in here was always 2 variables because we had to graph it. But what if you had 3? All right, I'll see you back here for chapter 4. Have a good one.